All right, guys, welcome back and thanks for staying with us. Right, in the previous video, we proved these two sum angles identities. Right, now we're going to take it a little step further, but before we go a step further, we're going to look at another identity that's going to help us to find what the difference of these angles are equal to. So let's start with the unit circle. If we have the unit circle here, just like that, and I need to come down just like that and just complete it like that. We're not going to use this side, we're just going to focus on that side. So I know it doesn't look like a circle, but it will get the job done. All right, so we're going to again get our hypotenuse right here, which is the radius, and we're going to draw a perpendicular line to the x-axis just like that. So this distance is 1, and again you're going in the x direction. It's the cosine of alpha or theta. Let's make that theta. And if you're going in the y direction, it's the sine of theta. Now, if we are going in the clockwise direction, what we get is a negative angle. So we're going to go there, we're going to make this x-axis again our initial side, and we're going to go in the clockwise direction to get our terminal side over here like this. Again, this is also 1, right? Because it's a radius of the circle. And then we're also going to draw a perpendicular line to the x-axis just like that. And to get some space in this area here, we're going to put the cosine of theta up top. Yeah, just going in the x direction. So this angle here would be negative theta, right? Now that we have this angle right here, we need to find what is the sine and cosine of this angle, this negative angle, on this unit circle. Let us go. All right, now notice that at this point right here, remember you're going in the fourth quadrant here, x is positive, y is negative. In the first quadrant here, x is positive, y is also positive, right? So just keep that in mind. Now remember that we said that the sine of the angle is equal to the y value, and the cosine of the angle is equal to the x value. So the sine, remember the sine of theta is equal to y, and the cosine of theta is equal to x, right? And we know that because the hypotenuse here is 1. Now, from that, we can look at what the cosine of negative theta is. So the cosine of negative theta is equal to, remember, it's the opposite, the adjacent, over the hypotenuse, right? The hypotenuse is 1, so we're going to have a 1. But what's the adjacent side? That's this side right here, which is the cosine of theta. That's the cosine of theta, right? Because it's this distance, right? So it means that the cosine of negative theta is equal to the cosine of theta, because cosine of theta over 1 is just the cosine of theta. So that property holds. Let's write that a little bit better. So it's the cosine of theta. There we go. And we can also look at the sine of negative theta. So the sine of negative theta is equal to the opposite side over the adjacent, over the hypotenuse, So the opposite side is this distance right here in the y direction, and that's negative y, right? So I'm going to put negative y for now, because I want to show you guys how it gets to the negative sine of theta over 1, right? And if you recall over here, y is equal to what? The sine of theta. So if we replace y with the sine of theta here, we get that the sine of negative theta is equal to the negative sine of theta over 1. That's just equal to the negative sine of theta. So we don't have to put that one right there. So that's a nice little identity that we have here. Now, if the cosine of negative theta is equal to theta, so if the cosine of theta, and the sine of negative theta is equal to negative sine of theta, it means that the tangent of negative theta will also be negative because sine is negative. So the tangent of negative theta, remember the tangent of the angle is equal to the opposite over the adjacent. The tangent is equal to the opposite, that's this length, where we say that's negative sine of theta, but we could write it as sine of negative theta first over the cosine of negative theta, right? And we know that the sine of negative theta is equal to the negative sine of theta, and the cosine of negative theta is equal to the cosine of theta. So therefore, the tangent of negative theta is equal to negative sine of theta over cosine of theta, which results in just the negative tangent of theta. So the tangent of negative theta is just equal to the negative tangent of theta. And to save us some space, we're just going to write that down below here. So it's equal to the negative tangent of theta. See, didn't skip any step. So you saw how we got to that. All right, let's go here. Now we can look at the reciprocal of these functions, which is the cosecant, secant, and cotangent. So it's just a reciprocal of what we have here, right? So it means that the secant of negative theta is equal to 1 over the cosine of theta. Because it would be 1 over the cosine of negative theta, but the cosine of negative theta is also equal to the cosine of theta. The cosecant of negative theta is going to be equal to the negative 1 over the sine of theta. Because the sine of negative theta is equal to the negative sine of theta. So it's a negative 1 over sine of theta. And then the cotangent of negative theta is equal to the reciprocal of tangent, right? It would be 1 over the negative tangent of theta. That's what it would be equal to, because it's a reciprocal, right? And 1 over the tangent of theta is equal to the cotangent of theta. So it simplifies to just the negative cotangent of theta. And these are some nice properties to know, right? Why do we need to know this? Because we're going to look at the difference of the angles, what they are equal to, and then we look at the tangent of the sum and difference of the angles, right? So let us go. We're finished with the unit circle for now, so we're going to remove it from this space. And let's go. Now, if we want to know what the sine of alpha minus theta is, we're going to treat that as the negative angle. We know that that's equal to the sine of alpha cosine of negative theta. Just going to put that, and I'm going to put in parentheses like that, so you see what's happening, plus the sine of alpha cosine of theta. No, it's the other way around. Sine of theta cosine of alpha. There we go. Oh, we had to fix this right here. Theta. Nice. So this is what we have, right? Oh, this should be negative. There we go. Let's put that in green. There we go. Nice. So the sine of alpha minus theta is equal to the sine of theta cosine of negative theta, sorry, this is alpha, plus the sine of negative theta cosine of alpha. So we know that the cosine of negative alpha right here is equal to the cosine of theta. The cosine of negative theta is equal to the cosine of theta. Don't know why we're getting theta and alpha mixed up. All right, but let's go. So this is just equal to the sine of alpha cosine of theta. But we have a plus sign, and the sine of negative theta is equal to the negative sine of theta. So we're going to take that negative out front, sine of theta cosine of alpha, right? Two signs meet, let's put that in parentheses. So what we're going to do is to just turn this into a subtraction problem, right? And take the additive inverse of what's on that side. So this simplifies to the sine of theta, sine of alpha, cosine of theta, minus, change the operation from addition to subtraction, take the additive inverse of what's on that side, which would be the positive of sine theta cosine alpha. And that's how we got to the sine of alpha minus theta is equal to the sine of theta alpha cosine theta minus sine theta cosine alpha. And it's the same idea with the cosine. If you notice, we have a plus sign here. What's the difference? It's just a subtraction sign here. It's just going to be changed to a addition sign, right? Because that's how we know it's the cosine function. It switches. If it's a plus here, if you're summing the angle, you're subtracting here. If you're subtracting here, you're adding here. But with sine, it stays the same. If you're adding here, you're adding here. If you're subtracting here, you're subtracting here. So we proved that one. We're going to go to the cosine here. Let's go prove that one. So because we already proved that one, we're going to write it like this up here. The plus and minus, and we're going to have a plus and minus, just like that. Now the cosine of alpha minus theta is equal to, let's write, the cosine of negative theta sine of alpha minus the sine of negative theta sine of alpha, right? And should I put that in red so you see what's happening here? Let's put that in red. Right here and right here. So again, we know that the cosine of negative theta is equal to the cosine of theta. So that's just a cosine of theta sine of alpha. We're subtracting. We're going to take the negative out front again. So that's negative sine of theta sine of alpha. Put that in parentheses. We got two signs right there. The cosine of theta sine of alpha. We're changing the subtraction problem to an addition one. So we're taking the additive inverse of what's on that side. It's negative here, so we're going to put it as a positive sine theta sine alpha. So that is why the cosine of theta minus alpha is equal to the cosine theta sine alpha sine theta sine alpha. Right? Wait. It's cosine, guys. Does it sound right? Cosine. 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 Another mistake. Still not doing that over. We all make mistakes. No worries. Once we figure out that we made the mistake, we make a correction, right? So it should be cosine, right? So now all we have to do to modify what we did here is to put these as, we're going to have a plus. We're going to have a plus or minus here, and then you have a minus then plus. Notice that it's the opposite. So if you're using a plus sign here, it's going to be a minus sign here. If you're using a minus sign here, you're going to be a plus sign here, right? So now we can move on to the tangent of the sum and difference of the angle. So let's get rid of these pieces. Right, nice. And we're finished with these for now. We're just going to recall a few of them probably later or probably in the next video, but we're finished with these for now. All right. We're going to look at the tangent of the angles now. That's the tangent of theta plus alpha. Now that's just equal to the sine of theta plus alpha over the cosine of theta plus alpha, right? And we know that the sine of theta plus alpha is equal to this, and the cosine of theta plus alpha is equal to this, right? And again, we're adding, and we're adding. So we're going to use the addition one for that, and we're going to use the addition one for this, all right? So we're going to replace the sine of theta plus alpha with the sine of theta cosine of alpha plus the sine of alpha cosine of theta. Hope we don't get anyone. I'm looking carefully this time, right? So that we don't make any mistakes, right? And below here, we're going to take the cosine of theta plus alpha, which is going to be the cosine of theta cosine of alpha, minus the sine of theta sine of alpha. So it's going to be equal to the cosine of theta cosine of alpha minus the sine of theta sine of alpha. Nice. Now I know that it doesn't look like the one that we always see, where it's the sum of the angles over 1 minus the product of the angle, but we can get it looking like that by doing one step. This is the one step. We're going to divide both the numerator and the denominator by the cosine of theta cosine of alpha. Cosine of theta cosine of alpha. And I'm going to do it right here so you can see what cancels and what stays, right? So we're going to divide the entire numerator by the cosine of theta cosine of alpha and the entire denominator by the cosine of theta cosine of alpha. Let's go. So we have this is equal to the sine of theta cosine of alpha divided by the cosine of theta cosine of alpha plus the sine of alpha cosine of theta. We're dividing that by, let's put in a different color so it doesn't get confusing. Cosine of theta cosine of alpha, right? Let's put this cosine theta cosine alpha, right? And we're dividing all of that by, again, we're dividing also the denominator by the cosine of theta cosine of alpha. So it's the cosine of, I should be in red, it's the cosine of theta cosine of alpha divided by the cosine of theta cosine of alpha minus the sine of theta sine of alpha divided by the cosine of theta cosine of alpha, right? Now, let's see what cancels out. So, as we go through, notice here the cosine of alpha cancels with the cosine of alpha in the numerator. Over here, the cosine of theta cancels with the cosine of theta here. Here, this entire thing cancels with this one. So we just have a 1 right here. And this over here, we have just the sine of theta over the cosine of theta and the sine of alpha over the sine of alpha, which we're going to split that up. We could represent that as the sine of theta over the cosine of alpha multiplied by, let's move that piece, multiplied by the sine of alpha over the sine of, over the cosine of alpha, right? So that way we could rewrite them as the tangent. You see where we're going, right? So notice we have sine over cosine, that's just equal to, so this is equal to, sine over cosine is just a tangent of theta, because that's the angle, plus sine over cosine, again, the tangent of alpha, all over, remember this cancels out, gives us 1. We're subtracting the product, the tangent of theta and the tangent of alpha. And that is what we are familiar with. So the tangent of theta plus alpha is equal to the tangent of theta plus the tangent of alpha divided by 1 minus the tangent of theta times the tangent of alpha. Now, with the sign change, if you notice what's happening, when you're adding in the numerator, you're adding also, but in the denominator, you're subtracting. So it means that if we were to incorporate the signs of our subtraction here, it's going to be the opposite over here. So it's going to be, if we do, let's put plus or minus. If we put plus or minus here, because the plus in the numerator, subtraction in the denominator, it means that this will change to plus or minus also, because it remains the same in the numerator, but in the denominator it will go from minus then plus, right? What that means is if you're taking the sum of the angle, it's also the tan of theta plus the tangent of alpha over 1 minus the tangent of theta, tangent of alpha. But if you're taking the difference of the angles, it's the tangent of theta minus the tangent of alpha over 1 plus the tangent of theta, tangent of alpha, right? Nice little proof right here, right? And we're going to pause right here because in the next video, we're going to look at the half angle identities. All right. Thank you guys for watching. I'll see you in the next video.